everyone, I believe it's 2 o'clock, so time to start this presentation. I'm Justin Lemire-Elmore, the owner and founder of Grin Technologies. We're a company that specializes in manufacturing, engineering, distributing, selling parts to convert bikes into electric assist. This is the first time for us to actually do a live conversion on stage in the time pressure of a 30-minute time window. And the point of this talk is to sort of demystify what the process is of converting a regular bike into an electric bike, and to show that it's not that complicated of a process. Anyone who's mechanically adept enough to fix or work on bikes should be comfortable with putting a conversion kit on a normal bicycle. So here we're fortunate enough to have a bicycle this isn't just a staged installation. We actually have a customer in the audience. I believe it's Carolyn over there with the thumbs up. So she has this bicycle that she loves. It's a step-through frame bike that makes it very easy for getting on and off. And with the turnkey electric bicycles that are out there, there weren't many models that had the same appeal that she had as a bike that she could ride. So this is one of the main reasons people will choose a conversion over a factory bike, because they already have a bike that suits them, that's personalized to their needs, and a conversion kit allows them to then upgrade that bicycle to have all the benefits of electric assist. On this bicycle, it's a 3-speed bike. It has a 3-speed internal hub on it, and that eliminates the possibility of doing a rear hub motor, because if you put a motor on, you need to have a derailleur system to change the gears. So that gave us options then of putting a motor either in the front or putting a motor on the cranks. Now, because of the unusual geometry of this bike, where the bottom bracket is connected to the seat tube rather than connected to a junction point, the bottom bracket conversions, the mid-drives that go on the bottom bracket, won't fit mechanically. Because it's also got a 3-speed hub on the back, if she was to install a mid-drive kit, it would be putting more power into this hub than the hub is rated for, and there'd be a high risk of actually causing the pawls and the gears in the 3-speed hub to fail. So really that forced the only option to be a front hub motor, which is great because there's a ton of front hub motor options, and a front hub is the easiest motor option to install on a conversion kit. So as our first go-to choice, we would always look, is a front hub suitable? If so, then we would go over the range of front motors, because they have the easiest installation and the least likelihood of compatibility problems. So the other thing about this bike frame is that it's not a conventional triangle frame like you see on most bikes, where you have a straight down tube on which you could mount a battery. So on this bike, there are water bottle mounts on this curved tube here, but if we were to physically put one of the down tube mounted batteries, it would block this channel where you use for the step through for the frame conversion. So that rules out the option of a frame mounted battery, which is kind of the most popular choice for a conversion kit because it keeps the center of gravity low. And that forces us to rethink, step back, and look at the other possibilities. So one option is to put a battery in the front. So we have some flat batteries that we would have thought could fit flat on the bottom and still let you use the basket, but they were about ½ an inch too long for this particular basket. So that really forced us to go from the get-go looking at our rear rack battery options. A lot of bicycles already have a rear rack on them, and we have a range of adapter plates that will let you mount a battery, have it click and lock on to your existing rack. If the bike doesn't have a rack, then the companies that produce these rack batteries often supply a rack for you. And in this case, we'll be using the battery rack that comes with the battery, and that I'll discuss in a minute some of the benefits of going with the dedicated rack option. So having decided that we're doing a rack battery and a front hub motor, we're going to look at the components of the kit that we're going to install, as well as the tools that are necessary for doing this installation. First and foremost, we have the actual motorized wheel. So at our shop, we carry a whole range of different hub motors. Most of them, as we stock them, are not laced into a rim. It's just the bare hub. And then we would build it into a wheel so that the customer picks up a ready-to-go wheel like this. So this wheel will then just swap out for the existing front wheel. This here is the rack that I was just discussing. So this is a double-decker rack. So it has a cavity for the battery to fit inside and still leaves a fresh top surface, so that you have the option of installing a trunk bag or carrying cargo on top. If you have a conventional rack that you then put an adapter on, the battery will sit on that, but you'll have a difficult time mounting additional gear on top of the battery pack. The battery itself here is an easy flat pack battery. This one's 36 volts, 20 amp hours. That gives us about 720 watt hours of energy. And on a typical consumption rate, that is equivalent to 70 kilometers of distance. So there are smaller batteries and larger batteries, but at this point, most batteries will be in the 50 to 80 kilometer range, and this is sort of on the higher side of that. There's a component to the conversion kit that most people won't be familiar with unless they're experienced with electric motors, and that's the motor controller. And so the battery pack provides DC power, able to run a system, but the hub motor itself is alternating current. It's a three-phase brushless motor. And when you're on the bike, you want to be able to modulate and vary the power going to the motor. So you can't just plug a motor straight to the battery. You need some control circuit in between that doles out the power and converts the direct current into alternating current. And that's the job of the motor controller. Now in this conversion kit, the motor controller is a separate entity. It's a separate black box. Some of the conversion kits will hide the motor controller. Either they might fit it actually inside the motor, which you can do on the bigger motors, or they might mount the motor controller inside the battery pack. Those have advantages for having a clean installation because you don't have this extra part, but it has downsides for substitutability and upgradability down the road, because if you have an electronic failure, it's not easy to swap something out that's integrated that way. For controlling the bicycle itself, we're going to do an installation here where we use a throttle control. So this is a thumb throttle lever, so as you ride, you can just control exactly the power that you get by pushing this lever with your thumb. There's also options for twist grips, more like on a motorcycle. A twist grip can be handier for long duration riding because you don't have to have your thumb extended, but it's easier to accidentally twist the throttle if you're just walking the bike to lock it to a rack. If you're not mindful, you can twist the throttle by mistake and have the motor take off. It's also possible to install pedal sensors on any conversion kit where there's a system that detects when you're pedaling or how hard you're pedaling and then regulates the power automatically. That we wouldn't be able to fit into a 30-minute installation, so here we're going to show the install up to the point of a throttle control. There's also a range of display options. So most conversion kits now will come with a display that gives you the basic information on the charge level on your battery pack as well as the speed of the bike. This is a fairly technical display that we produce, but it will show on its main screen a battery icon showing how full your battery is and give you your speed, your distance. But it also gives a lot more interesting information that as you gain familiarity with the bike, you start to understand exactly how many amp hours the battery produces, and you see what your energy usage is like in a unit called watt hours per kilometer. And with that information, you can predict with very high accuracy how far you'll get with any given battery, and you can see as you change your riding habits exactly how that's going to affect your range. So it's a bit of an educational tool to inform people about how their electrical system's working and behaving. Over here we have stuff that facilitates the electrical installation. So cable ties are front and foremost the main way that you deal to handle the keeping the cables routed close to the bike frame. There's these Velcro stretchy sleeves, and these are just a fabric that you can use to wrap around the tubing or the cable bundles and tuck away all the connectors so that it's concealed from view and results in a more aesthetic finish. One of my favorite components in the installation is spiral wrap, and this is a plastic tubing that's cut into spiral, and it allows you to bundle all the electrical wires to the existing brake housing or shifter housing so that visually and aesthetically you just have one cable run. You don't see 5 or 6 parallel wires. In the absence of this, a lot of people will run a bunch of zip ties side by side, but this has a much cleaner look. Now the tools for the installation here is really 3 things. So I have side cutters for cutting zip ties. That's really the only function of that. There's an Allen set, and that's used for removing components on the bike. And then a wrench is required for installing the motor itself. Okay, so with a front wheel, you have to be a little bit careful about what is the forwards and the reverse direction of rotation. And the cue that you have for any of the motors that we sell is that the front motors all have a disc brake mount, and the disc brake is always on the left side of a front fork. If you make a mistake and install it backwards, you'll be surprised the moment you hit the throttle. Luckily, we're going to hit the throttle before we sit on the bike to make sure everything's good that way. There's another consideration with the installation, which is the exit on the wires. And you generally want the cable to exit pointing downwards. So if you install this wheel and you have the wire sticking up like that, then the wire can become a point of water ingress. So if there's any break in the seal, it'll track water into the hub. If the cable exit pointing down, then water will drip to the bottom of the loop and fall off. It won't climb its way back up and into that seal. So always try to have cable exits on the underside. So here I've removed the hardware that was on it. We're going to slide this up into the fork. So at about 60 to 70% of the bicycles, the front wheel will just slide into the fork like that. about 30 to 40% of the time, you'll try to get it in and it'll actually get stuck. It won't fit inside there because the width of this slot, which is called the dropout slot, is a little bit narrower than the axle of the hub motor. So if that's the situation, don't panic. Simply get a file and file away. It's usually about 0.2 millimeters at most that you have to remove, and you just carefully file a bit at a time until it just fits in. If you file too much and you open that slot too large, you reduce the ability of the dropout to prevent the axle from spinning. And we're going to talk a little bit about the axle spinning when I rotate this to the other side. For now, I've got the wheel up in here. I'm going to reinstall the hardware. And now what I'm going to do is I'm going to rotate the wheel so you can see what's going on the other side. And here we have a little bit more going on. So in this bike, you see a couple plates of metal here. This is what's called a torque arm. And a torque arm is there to take the force on the axle that's causing the axle to want to spin, and it's now linking it. We're going to bolt it to the bolt that holds this fender on. And that removes any stresses from the metal dropout and transfers it further up the fork so that you have more security against that rotating torque that the electric motor is going to impose on it. This bike has steel forks. It's a steel fork with steel dropouts. This torque arm is not really necessary for this low power motor, but we're going to include it on the installation because most newer bikes these days are going to have aluminum forks or carbon forks with aluminum dropouts. And aluminum is not strong enough of a material to resist the rotating force that's going to want to spread that open. Now I'm going to line the fender mount itself so that we're lined up in here. Put this bolt back on. Okay, and definitely all the hardware needs to be quite tight so that we don't risk things loosening over time. And Sasha's now holding the wheel so it's seated all the way into the dropout. If you're doing this at home, you'd normally have the bike on the ground, and the weight of the bike will itself help push the axle all the way up into the top of the dropout. Okay, and at this stage here, I'm going to tighten up the axle nuts. We have this torque arm to help prevent the spin out, but you also want to make sure that you always do the nuts up really good because the friction of the nut compressing the axle also helps hold that axle from spinning. Great. Okay, so now the front hub's installed. So the next step of this installation is going to be mounting the rack for the battery pack and getting the battery on there. So I'll rotate that so the wheel stays put. Luckily, most bike frames include mounting bosses to install a rack. This bike is no exception. It has two eyelets at the front here for the front of the rack, and then extra threaded holes in the dropout plate for the back of the rack. Some newer bikes tend to avoid any extra bosses like that, and in that case, there's little clamps that can clamp around the tubing in order to provide a location for supporting the front side of the rack. So this rack, you can see that it has an adjustable height, so this will fit from 24-inch up to 700C wheels. So if this was going on a larger wheel frame, then we would remove those bolts and just extend the height of it. When you have a battery on a rack like this, it's well within the weight limitations of most bicycle racks. Typically, racks will be rated for 10 to 50 and up to 25 kilos. The battery that we're installing here is 3.9 kilos. But the battery is really rigidly secured to the frame. If you put 10 kilos of camping gear in a pack, it's kind of loose, and so when you hit bumps and are on bumpy terrain, that weight doesn't have quite the same shock factor as the battery, which doesn't really have any cushioning. So our experience is that batteries, even though they're lighter than the ratings on the rack, they cause more problems with fasteners getting loose or aluminum fatigue failing. So you want to keep an eye ensuring that your hardware is done up tight, but most importantly that you have lock washers under a lot of these bolts, because with that extra impact force, there's a higher likelihood of the bolts coming unloose. We've had situations with customers where these two bolts in the front have rattled themselves out, and then the entire rack is supported just by those two, and the battery falls over backwards and drags along the pavement. Everything survived, but you want to avoid those situations. So be mindful of securing those bolts tightly and using a lock washer or a Loctite when you can. So with the rack installed, I can now put the battery on. This particular battery, it has a key switch that serves two functions. When I turn this key, not only do you see a pin that locks the battery mechanically into a mating plate on the rack, that key switch is also turning the battery on and off. So you can turn the battery on and lock it, remove the key from the battery, and then it's locked on the bike, and you can turn it off to turn the system off without undoing the lock, take the key out, and now the battery is locked on here and the system is off. When you want to slide it on the rail, you have to make sure that that pin is all the way retracted and so that the battery's in the open position with the pin all the way in. So now I can slide the pack through here. Okay, slide it until it bottoms out. Now I'm turning the key from this side, and then the battery is locked in place. You can't pull that out, and now the key switch is serving as an on-off switch for the bike system pack. So now we have two of the three key components installed on the bicycle. We have the motor, we have the battery pack. That leaves us with the motor controller, that mystery black box that takes this direct current power and converts it to alternating power. Much of the time spent doing an installation involves dry running where's the optimal place to put this electronic box so that your cables are all long enough to reach where you need to go, and the box is, this electrical box is in a position that's out of the way of your pedaling and that looks good on the bicycle. So the people who design these motor controllers are not really sophisticated design engineers for bicycle parts, so they tend to often be generic looking boxes, and it's hard to usually fit a square piece of electrical equipment on a bicycle where everything is round tubing and triangular angles. Luckily, when you install a rear rack on a bike, it produces this kind of dead zone between the seat tube and the rack itself with those rails that provides a really convenient location to tuck away a motor controller. So if you install the controller here, it's not visually getting in the way of the bicycle, it's out of the way from being inadvertently hit or turned on and off, and it works as a place to mount the motor controller box. So this box, as with many motor controllers, it doesn't come with specific hardware to clamp it to the bike. It just has a flange with holes in it, and we're going to use cable ties going through those holes in order to lock it to the bike frame. So I'm running the electrical cables straight down behind the seat tube. The one exception is going to be the cable that connects to the battery that's going to run backwards here. Okay, so the motor controller is going to sit here. Before I lock everything into place, I'm going to do a dry run of all the cables to make sure that everything fits so that I don't have to cut off the attachment point and reposition things a little bit. So I'll just let it sit there temporarily. And now what we're going to do is finish hooking up the other parts of the system. So one of the parts that has to plug into the motor controller is that throttle. So here we remove the grip. Most bicycle grips are going to be more difficult to slide off than that. You're going to have to use compressed air, really work it to slide it off. And now the throttle itself. Here we're installing the throttle on the left side of the handlebar. Throttles are available for both right and left sides. Because the shifter's on the right, there's some benefit to putting the throttle on the left rather than having too many controls on one side of the bars. But it's just as possible to remove this side off, but because of the excess width of that shifter, the throttle would be a bit of a reach for the thumb in order to engage it. Here, there's nothing like that blocking the way. Okay, so this throttle cable is not long enough to reach the motor controller back there, and we have a range of extension cables available. This throttle cable is the right length to plug into a display that takes a throttle. In this more simplified display, we're going to run straight to the motor controller at the back. Okay, and so this cable, we're hoping that we'll be able to have it follow the existing shifter housing and then work its way up over to the throttle on the left side there. While we're wiring things up, we also have to connect the motor to the motor controller. So all of the motors tend to have a short cable out of them, and the reason for that is that if you have to take the wheel off for fixing a flat tire, you don't want to have to undo all the wiring that connects it over to the motor controller if the connection's back there. So we always strive to keep a short cable to a connector so that you can unplug it right at the fork and not have to undo your wiring if you need to do a wheel swap. So in this case, again, we have a standard extension cable. The cable that comes on this motor controller itself, I ran it down here. It's the right length if this was a normal bicycle frame to come across the top tube and down the fork. Because we have this extra U-shape to travel, the stock length isn't quite enough, and so the extension steps in here to make up the difference. So these connectors, they have an arrow to help you align the pins, and it's a nice waterproof connector, so you don't have to worry about sealing or covering the connector. So this cable, we're going to run it up, and I said I want all my wiring to follow the shifter guide, so I'm actually going to pass it on to the other side of the bike frame so we can bundle those wires together. So this will come down here, and that's going to plug in over here. So again, I look for the arrow to align it. So now at a high level, I've plugged these things in, and you can see I have sufficient cable length that I can run everything together. So now the last thing that we're going to need to wire up is the display computer. So this also is going to plug into the motor controller. And here, the stock cable length, we tested this before, but it's just exactly the right length to reach. So we don't need an extension anymore. This will clamp on the handlebars. Okay, and now the cable, again, we're going to follow the existing housing. We're going to run it under through here. It's going to come up the side. So here, all the connectors in this and any e-bike system are always going to be plug and play. There's no ambiguity as far as which plug goes to which connector. The connectors have a label on them, but they also have a different number of pins, so you can't get it wrong. There's only one way you can hook things up, so you don't need any electrical knowledge. You don't have to know how to solder, crimp connectors, or deal with pinouts. It's going to be unambiguously plug and play compatible. So now everything is plugged in except the battery pack. I'll plug the battery in here. And typically, this is where I would test to make sure the system works. So before we go through the effort of really neatly routing all the cables, we want to make sure that when we do that and turn it on, the wheel's going to spin. If we've overlooked something or there's a defective component, it would be a waste to undo all of that work. So now I'm going to turn the battery on. And then the motor controller itself has an on-off button. So this is usually the primary means that you use to turn the bike on and off. So I turn it on there, and a little kick of power. You can see the LED light is on the motor controller, and it's steady. A lot of these motor controllers, a steady light means everything's good, and if it's blinking, it means there's a problem. So if I was to, say, disconnect the throttle, you would see a blinking pattern on there saying it doesn't see a throttle signal. So now I want to make sure that the motor actually runs, so we're going to ensure no cables get tangled in here. And I'm just going to hit the throttle and see that we have power, and we have power. Phew. Okay? One thing you'll notice is that the wheel's spinning. This is a geared motor, so it has no resistance. So it'll spin freely like a normal bicycle hub. Normally, I would squeeze the brakes to stop it. This bike doesn't have any front brakes. So this is a really simple bike that's kind of a minimal set of components, and it's relying on a coaster brake on the back for stopping. Normally on an electric bicycle, we'd really advise having a bike with pretty good brakes on it because you're able to move faster, you're able to carry more stuff. But this fork itself doesn't have the facility for mounting a disc brake or for mounting rim brakes. So we're going to advise the customer to be mindful not to take it too fast because the only braking that they have available is the coaster brake. So now what we have to do is make this look good. And this is where a lot of people doing DIY conversions fail to put the time and attention into making, refining the wiring and the cable routing to have the look of a finished turnkey factory bike. And it's totally possible to make this look as clean as any of the bikes that you see on the floor there. And that's what I'm going to show, I guess, in the next 3 or 4 minutes, which is all the time I have left. But that's usually where a significant portion of the time can be spent if you really want to be a perfectionist about it. So I'd mentioned previously that one of my favorite tools for doing that is spiral wrap because it lets us bundle all the cables together. And could you get me my snit? Thank you. So here what we want to do is have all of these cables running into a single bundle. And so starting up here, I'm going to cut a length of spiral wrap that gets me to the next mounting boss on the frame. At this stage, I'm doing it a little bit loose because we're going to be shifting the wires up and down in order to make sure that the length will be able to route properly under the bottom. So I mentioned that cable ties are really useful too, but I generally want to minimize the use of cable ties because they wrap around the tubing and it looks like a visual distraction. So the spiral wrap can use the existing cable as a guide without putting a band around the frame tubing. So here it's appropriate to install a cable tie. One thing I'm not going to do is mount a cable tie right close to the motor because of the reasons I talked about earlier. If you have to take this off to fix a flat tire, you don't want to have to cut cable ties in order to do that. So I'm going to actually mount this first cable tie further up. So we're going to put one right up at the crown of the fork, right about there. Okay, and that's all we need in order to hold the cable neatly. It's not going to get tangled in the spoke. We could put a second one right there if we want to, and that holds that in place. So now we have this whole cable bundle, and our hope, so the existing cable normally would follow that all the way, but that tucks itself inside the frame tubing. And so that's something that a lot of bicycles will do to look really slick. They'll run the brake of the derailleur cables through the frame. It is a nightmare to service or work on that. So if you really want, you could try to feed your electrical cables through there too. We highly advise against it from a service perspective. So what we're going to do is follow it as long as we can, but then we're not going to chase it through the tube. We're going to go outside. And here we have to be a little bit cautious because this is fairly low to the ground, and we don't want the cables right under the bottom. So there's a risk of the electrical wires getting smashed if this bike, if you drop a curb and that becomes a point of impact. We don't really want it on the top because of the risk when you're stepping over the bike that you might step on that and smear the cables. So for us, the ideal place is going to be right on the side. So we're going to have this set of cables run and then follow just on the side of that tubing there. So now I'm going to put a few pieces of spiral wrap to hold it down this down tube. When you run these cables, if you really want it to look great, you try to keep the cables parallel to each other. If the cables cross and zigzag over, you'll cover it with the spiral wrap, but you'll see lumps on the spiral wrap, and it doesn't look quite as good as a neatly attentive, perfectly parallel set of cables. All right, that's looking pretty good. So now we're at the point where we have to branch away from the existing shift housing and have our electrical cables follow this kind of alternate path. And here, in order to keep them on the side, I'm going to use the cable tie. If I can fit one right here, that would look better than having one right in the middle. So let's see if that does the trick. Now we have a longer stretch here, so I'm going to cut a piece of spiral wrap about the same length as that straight mark. A clean line there. I deliberately left this cable tie loose for now because we're still going to be fudging the position of the cables to make sure that everything reaches. An important thing to check is that you can steer the handlebars all the way left and right. So some people will do an installation, the handlebars are straight, it looks great, and then the moment you steer to the left, it tightens up, yanks the cables, and risks pulling a connector out. So you want to make sure that you have the freedom to do full steering of the bars. This one clears that pretty well. But you'll notice there's a bit of extra cable for the motor mount itself. And this cable here, it's going to be a little bit tricky to absorb it up here. So I'm actually going to fish this back through and then give ourselves a bit more of a loop here. So that gives us more extra length for turning the wheels. And it's going to look a bit better actually having it come out and feed its way back. I also mentioned early on about these Velcro sleeves. And the Velcro sleeve is a great way to cover up all the connectors themselves. So here you see this cluster of cable connectors. Now that we have our length all sorted out, we can wrap that inside a sleeve like this and then convert what was once sort of a hair mess of wires into just a simple black interface. With a smaller diameter tubing, you can actually wrap it to the tubing so that it holds it tight against the frame of the bicycle. This tubing is a little bit large for that. Okay, so Sasha's now putting cable ties through the holes that link the motor controller to the support tubes of the front rack. Okay, and that's pretty much the end of it. But that's how you can install a bike conversion kit on your bicycle. We hope that that lowers, from your perspective, the barriers that you might have faced when considering whether this is viable or not for you. I'd like to open the floor for any questions if anybody in the audience has any questions for us. Yes?
What are the extra wires hanging down?
Great question. So he's asking what are the extra wires hanging down. So one of these wires here actually has the battery power available to it. And so this is able to run a front light. So if the person wants to have a front light that's not run off its own batteries but runs off the main battery pack here, this would just plug into a front light. The second extra wire we have dangling down is for programming and updating the firmware on the display computer. So what we would do here, if there's no front light, we would put another one of these Velcro sleeves to keep those spare connectors bundled and out of the way of the site. And then we can contain those extra connectors there. Any additional questions? Yes? Yeah, so the question was if you're a bike that has internal gears at the back, you're talking about internal gear hubs?
external gears?
Oh, if you have a bike with external gears, if you use a bicycle with normal derailleur gears, then you have the option of putting a motor on the rear or the front. So most of the rear bicycle motors have a cassette free hub or a screw-on freewheel, so you can put a 7, 8, 9, 10, or even an 11-speed cluster, and then have a rear motor. And so that's also perfectly viable. And in that case, you have both options at your disposal. So if you prefer the rear for various reasons, you can install it on the back. That wasn't an option with this one because of the coaster brake and the internal three-stage. Yes? So the question is, what's a typical conversion cost? So stuff from our shop tends to be in the $1,200 to $2,000 price range for the components. A big chunk of that is the battery pack itself. So a battery pack will usually be between $600 to $1,500, whereas the motor tends to be less expensive in the $200 to $500 price range, and the motor controller can be anywhere from $100 to $250 to $300. And the additional cost is mostly in getting a larger battery for greater range. As I mentioned, this is a pretty high capacity battery. It'll do 70 kilometers on a charge, but as a result, it's more expensive than the more introductory price battery.